All right, we're going to talk about drawing Newman projections. We've already talked about this in class, but to give you some further insight about the perspective and the projections of these atoms and how to look at the molecule and exactly what you're seeing and what you are drawing when you draw a Newman projection. So, if I have a molecule like this, and I have a BR on a wedge and H on a dash, and I go to this other carbon and I have a H on the wedge and a Cl on the dash. So when we look at this molecule as it is now, we're essentially looking at it like we're looking at the side of a car. If you're standing on the sidewalk and a car passes by you, you would see the side of this car. But in order to draw this Newman projection, you have to be able to visualize and you have to be able to see that you are actually looking at the molecule from the front or the back, contingent upon which axis that you're looking at. So the best analogy I can use for that is if you're standing in the street and you see the car coming at you like this is the way your Newman projection is drawn. If you're standing in the street and you see the car from behind in the tail lights, your Newman projection is drawn like that. Okay. Um, the perspective, the perspective or viewpoint is very important when looking at the molecule to draw the Newman projection. Okay, and that is not only true for the Newman projection, it's going to be true for the Fisher projection. So what this means is you have to visualize the molecule in 3 dimensions. Visualize the molecule in 3 dimensions. So when you visualize this molecule in 3 dimensions, you can determine what atoms are in the plane and two, you can determine what atoms, and I can say atoms or atom groups, are projected towards towards you or away from you. Okay? So if we look at this molecule that I've drawn up here, and we're looking at it from the side, we can see that a BR would be projected towards us and an H would be projected towards us, okay? Now, the third thing you must remember is you have to be given a frame of reference to look at the molecule. So by that, I mean you must be told to look in this direction, or you must be told to look in that direction. So that is the axis you are looking down. Okay? So the axis that you are looking down is very important. Now, your textbook uses an arrow. I like to use an eyeball. Using an eyeball, and a person is more effective than just the arrow. And you'll see what I mean by that in a minute. So if you can use a person, you can distinctly determine your left and right side and deduce what is coming into the plane and out of the plane. Okay? Now, let's take a look at this molecule with this person. Okay? Now, everybody would agree that this is the molecule that I have drawn. When we look at it in three-dimensional, okay? So I have to tell you where to draw that Newman projection. This eyeball, this person's eyeball is actually right here, okay? Now, I can draw out that projection. And I can say that I have the CH3 group going down. I have, if you look, this individual is looking to the right. So this is going to be his right hand. Okay? So what's coming out towards you is going to be on his right side. Okay? So on the right, I need to put a BR. On the left, I need to put CH. Now, we know that the star now put a star like this or a star like this. We know this represents the front carbon. Okay. Now, a circle represents the back carbon. Okay, so we have a star representing the front, circle representing the back. So this would be our front carbon right here, and this would be the back. Okay, so on this back carbon, what I actually see is on my right side, I have a H coming out. On my left side, I have a Cl. And what's going up on this back carbon? You actually see this whole atom group going up, which is CH3. Okay? So when you're looking at that molecule, this is what you actually see. This is your front, and back behind that, which you can't see, that's your back carbon. And notice how the Br and of the front carbon and the H on the back carbon, they're on the same side. So you know you're on the right track with that. Notice how the hydrogen and the chlorine are on the same side. The hydrogen on the front carbon is on the same side as the chlorine on the back. So you're on the right track with that. And you can see this being true with your dash and wedge. The Br should be projected in the same direction that the hydrogen is on the second carbon. They should both be projected on the same side, which is coming towards you. And this hydrogen on the front carbon and chlorine on the back carbon should be projected on the same side. And we see that this is true from our Newman projection. Okay? Now, let's look toward the left. Let's look from right to left. Okay? And I'm going to identify this as the front carbon. And I'm going to say that this is the back carbon. So actually he's not standing up here, he's standing down there. If I could move his body. Okay? So if that's the front carbon, notice that he's looking toward the left. Okay? So if he's looking toward the left, this is going to be his left hand. On the opposite side that you cannot see is his right hand. He's looking in that direction. Okay? The opposite direction. Okay? Notice that I've given you two things. I've given you the direction that you're looking, and I've told you what's the front carbon and what's the back carbon. So if I draw this projection, and what I actually see is on my left side, I would have this hydrogen. On my right side, I would have that chlorine. Now, what's coming up when I look at that molecule? What's coming up is this whole group right here is coming up. Do you see how it is coming up? So that is CH3 coming up. Okay. Now, on the back carbon, this is going to be your back carbon. Now, on the left side, I see Br. On the right side, I see H. And what is going down is going to be this whole atom group here going down, which is CH3. Okay? Now, double check your projections. Double check your projections and see if indeed this Br on the back carbon and this H on the front carbon, are they on the same left side? Well, yes, they are. Double check your projections again. Double check to see if this Cl here on the front carbon and this H here on the back carbon, are they on the same side? Well, yes, they are. Okay. Now, we're going to do one more complicated situation. It's not really complicated, but it's has a little bit more atoms and substituents. So let's draw this molecule like this. Let's say 2, 3, 4, 5, 6. And let's say Cl OCH3, and I'm going to put an OH, and I'm going to put an H. 1, 2, 3, 4, 5, 6. And instead of the normal CH3, I'm going to put a fluorine on that molecule. Okay? So, can we draw it without our three-dimensional figure? So our eyeball would be here. So I'm going to say this is the front and this is the back. Okay, so what we have is you're looking toward the right. So what's coming out of the plane is going to be on my right side. So I have Cl is going to be on my right, OCH3 is on my left, and this whole atom group here is going up, which is CH2, CH3. Okay? Now, my back carbon is going to be represented by this circle. All right? So, what's coming out on my back carbon is going to be on my right side is going to be OH. My left side is going to be on that dash, which is H. And what's going down is this whole atom group here. That whole atom group there is CH2, CH2F, not Br. I mean, not CH3. That is a CH2. This is another CH2. And bonded to that carbon is a F, not another hydrogen. Okay? Now, if we quickly look at the eyeball, This is exactly what you're seeing. Okay? See how he's looking in that direction? And what's coming out is going to be on his right hand. What's coming out of the plane is going to be on his right hand. This is your front. This is your back carbon. Okay? So in this molecule here, this is exactly how you see it. Front, carbon, and back here is going to be the back carbon. Now, you can see how that this easily makes your projection. You see you have a Cl coming to your right, O CH3 coming to your left. You see that this thing here is going up, which is your what? CH2, CH3. On your back carbon, you see you have this whole thing here going down, which is CH2, CH2F. Okay? And where you see this, you have this going up and to your right, which is OH. And this is up and to your left, which is H. So if you look up here, you see these are the identical projections. Okay? Now, let's see, can we draw this same projection from the opposite side without looking at the three-dimensional model? So I draw this again. 2, 3, 4, 5, 6. I put a Cl, OCH3. This is OH. And this is H. So eyeball, this time I'm going to specify this is the front carbon. This is the back carbon. So eyeball would be here. Okay. So if the eyeball is there, you're looking toward the left. Okay. If you're looking toward the left, what's coming out of the plane is going to be on your left side. So what I see going down is the CH2, CH2, and this should be a F right here. Okay. And what's coming out of the plane is going to be on my left side, so that's OH. What's going into the plane on the dash is going to be H. The back carbon. On the back carbon, let me look at this and see what I have. I have a CH2, CH3 going up, CH2, CH3, which is this thing here. That's going up, okay? What's coming out of the plane right here is going to be Cl. And what's going into the plane here is going to be OCH3. Okay? That is that Newman projection. Now, if we quickly insert the eyeball of the person, this is what we see. right there. So he is looking directly at that carbon. Okay. So this is what he sees by this being the front carbon. Okay. And this is going to be the back carbon. Okay. So do you see how that, say front, back. Okay. So do you see how this front carbon, I have this whole group pointing down. It points down. Coming off of this front carbon is going down. Just like it is here, it is going down. That bond is projecting down. So it would be CH2, CH2, and a fluorine. Okay. Do you see if I'm staring to the left, what's coming out of the plane is going to be on my left hand side. So I have to put this OH going up into the left. And what's going into the plane is going to be up my right hand side, which is that hydrogen. And you can clearly see that here. Look, this is OH. This is on the left. Okay. Look here and you see this hydrogen is on the right. Okay. Now, the back carbon here. Okay. So what's coming out of the plane is going to be down to my left, which is Cl. What's going into the plane is going to be on my right, which is OCH3. And what group is going up off of that carbon? When I say going up, you see this bond is projected up. So this whole group, this whole CH2, CH3 group is going up. Okay? All right, so hopefully this gives you more insight. If you have any questions, let me know via Canvas. And practice this Newman projection, both of these Newman projections, over and over again until you can understand, you can see the dimensionality and the projections of the different atoms in space.